All right, so for our warm-up today, we have to write arctan x as a power series using sigma notation. And I'm just going to dive right in and show you the answer, and we'll walk through it. Before I do this, I'm going to say this. There's two methods that you can use to do this. One is to just start from scratch and say, all right, I know that the derivative of arctan x is 1 over 1 plus x squared. And I want to write that 1 over 1 plus x squared in a form that's like a over 1 minus r, right? So if I can do that, then I can just go from there and build and take the integral and get it to match and be fine. If you can remember what we did yesterday, so yesterday, at the end of the lesson, we learned that 1 over 1 plus x was this. So if you've got this series, and we want 1 over 1 plus x squared, you can literally just replace the x with an x squared and jump right to this step. So if you know the series for 1 over 1 plus x, and you want the series for 1 over 1 plus x squared, you can just replace your x with an x squared and jump to that step. So we need the integral of 1 over 1 plus x squared. This way right here is just building it from scratch. So you rewrite it in a form that's like a over 1 minus r. That's your a, that's your r. So you get 1 times r to the n, and then you clean it up. Whenever you have a coefficient with your x, separate it. All right? You don't want to have 3x to the n. You want x to the n. So if you have a coefficient, separate it. Here, this negative, make it its own thing. So negative 1 to the n, x to the 2n. All right? Good. Now we need the integral of this. The integral of this, remember, just raise the power by 1, divide by the power. Remember, when you're integrating a power series, you integrate just with respect to x. So you just look at the x. Raise the power by 1, divide by that new power. Don't forget your plus c. Yes?
Would it be incorrect if you kept negative x squared in parentheses? And then just integrate
It wouldn't, no, because then you'll have the wrong power on your negative. Because then you'd have negative x to the 2n plus 1, and it's not. It's negative 1 to the n, not 2n plus 1. You've got to keep them separate. So you really do. You can have x plus c. So you can have x plus number, but you can't have 5x plus number. So, or negative x plus number, yes.
When I took the integral, I kept the 2 and x squared inside the parentheses. Am I allowed to do that? Or no?
The 2, what 2 are we talking about?
So x squared.
Oh,
x
no, yeah.
Oh, but then if
Oh,
you
yeah.
kept your x squared in a parenthesis, like had x squared to the n, then you'd have x squared to the n plus 1, which is x to the 2n plus 2, which is wrong.
Okay.
So if you just made it from n equals 1, it'll be the
Because it's
same.
not equivalent.
Because 2 is still a part of it.
Or you can just start it from n equals negative 1, right?
Okay, again, we don't want to have negative exponents when we've got any kind of a thing, so let's not start trying to change the n. There's no reason here to try to beat the system. The system's really not that hard, right? So if we just, whenever you have it, just keep your coefficients separate, have x to a power. Raise the power by 1, divide by that power. Yes?
What is the part where you have arctan 0 at the bottom?
Okay, that's the next step, right? So we get the integral, we have a plus c. We need to solve for c.
Oh yeah.
So we know that this whole thing is equal to arctan x. So you just pick a number and plug it in so that you can solve for c. So I picked 0. 0 is almost always your best bet, because then when you plug a 0 in, the whole sum goes to 0. So we end up with arctan 0 equals the sum of 0 plus c, so c is just 0. Because arctan 0 is 0, right? So 0 equals 0. Okay. So now you've got c equals 0, and then there's your final function for arctan x. Oh, you're good. What did you say? You're always going to forget to solve for c?
Don't.
It's, yeah, just don't.
What if I just forgot to write the C in the whole first place? And
You'd
then,
probably
oh
lose a
no,
point.
C was 0.
Yeah,
But what if I just told you this all in my head?
but I'm gonna be looking for the C with your antiderivative. I mean, it's not major, it's just a point.
It's huge.
It's not like a differential equation, you don't write the plus C, it's huge. It is huge,
Yeah.
right? But with this, not writing the plus C, to me, it's minor.
Yeah.
That's a minor detail. Good. Other questions before we move on into today's stuff? All right, so here we go. Representing functions with power series. So this is a continuation of yesterday's lesson. We're going to do more stuff where we have to learn how to take a given series and expand on it to get a new series. We're also going to review how to add and subtract series. And there's one more little thing at the end where we're going to use a bunch of given power series to find function values. And that's it. Should be fun. I love it that you guys are actually writing the objectives for the day. That's awesome. All right, good. First problem. We are going to use the series f of x equals arctan x to approximate the value of the integral from 0 to 3/4 of arctan x squared dx. And we're going to do this with an error that is less than 0.001. Don't shake your head, you haven't even started. It'll be good.
Something fine.
It's going to be fun. This one's not bad. You will need a calculator for this though. So if you don't have a calculator out, you're going to need to get your calculators out. Yes. I have a couple extras right here. Anyone else need to borrow one? You don't need it yet, but you will. Oh, yes. Do you normally use it for or do you?
No, I know.
Yeah, it's like,
All right. So from the warm-up, we know arctan x is this. We just figured it out. All right? So we've got this. We want the integral of the arctan of x squared. To actually integrate arctan x squared is not fun, right? If you had to actually do it. So it is not an easy integral. It is integrable, but it's not easy. So in order to get around actually finding the antiderivative of arctan x squared, what we're going to do instead is represent arctan x squared with a power series. We get the power series representation, we integrate the power series, which we know is an easy integral because it's just a polynomial, and then we use the power series to approximate the value of the actual integral. All right? So, we've got the power series for arctan x. We want the series for arctan x squared. There's a very simple way to do this.
plug in x squared.
You got it. All you do is plug an x squared in for the x in your existing power series.
So do you
So-
multiply 2n plus 1 like the whole times 2 then?
Yep, now we're going to take a second to do that. So I want you to rewrite a new series for arctan x squared. Everyone got it? Check your answers against each other's. Make sure they match. Yeah, you all good? Do you all have something that looks like that?
Wait, why would you
Yes.
multiply the 2, n plus 1 by 2 is 1?
Why would you?
There's no x on the bottom.
Yeah. I was just thinking because like the top and the bottom. are similar.
All you're doing, literally, is, it's kind of, like, think of this as like an arctan u. You're literally plugging an x squared in for that variable,
But
right?
then if we derive it and then we take the integral of it again, now then when we have a du over it, no, we can still get rid of it. Never mind.
Okay, good. All right, so now we've got arctan x squared. Everyone with me? But we don't just want arctan x squared, we want the integral of arctan x squared. So everyone take a minute now and integrate this guy. Hey, here's a word of comfort. Do you need a plus c?
Yes, you do.
No.
You do not need a plus c because this is a definite integral.
Oh, why do you say that?
Good. Okay, so everyone go ahead and find the integral and go ahead and plug in the limits, the integral limits, once you've got your integral. So when we take, I just rewrote the problem. So now we have the integral from 0 to 3/4 of this. Add 1 to the power, divide by the new power. Your new power is 4n plus 3. So we divide by 4n plus 3. So now we have the integral of this is this, and we want to evaluate it from 0 to 3/4. So you literally plug a 3/4 in for x, minus plug in a 0 for x. How are you doing? Is that okay? Okay. Yes?
When you plug in, are they still sums? Are they still?
Yep, they are still sums. What's the sum of 0? 0, right? As soon as you have a 0 plugged in, it gets multiplied by everything and the whole sum just goes to 0. So we are just left with this sum. This is our sum, our power series with our actual that represents this integral. So the integral from 0 to 3/4 of arctan x squared actually equals this. Now, we can't do this sum from 0 to infinity, so instead we're going to sum enough terms to get within 0.001 of the actual value. Let's pretend we couldn't actually find the actual value. We know 2 formulas for approximating error. The first formula we learned was the alternating series error formula. Alternating series, this was back in 9.5. It said this, it said, hey, if you have an alternating, is this an alternating series?
Yes.
How do you know?
Negative.
You got -1 at the end, okay. So if you have an alternating series, whichever term falls below the desired error, the max error you want, if you sum the preceding terms, that sum will be within that error, right? So if we want error that's less than 0.001, say the 10th term actually literally is less than 0.001, then you would sum the first 9 terms. And that sum would be within the desired error. That's for alternating series. Hey, this is an alternating series. Yay, so we can do that, right? Of course, the other method that we learned was the Lagrange error, which we did a tiny bit of in core for someone who had been out during that week. And just in case you're wondering, just a little review, that's the max value of the nth derivative, right? Times x to the n, x minus c to the n plus 1 over n plus 1 factorial, right? That one, right? You do that and you get the max error. So anyway, that's a fun one. That one's not so bad unless you get that max value of the derivative being a pain, right? So, which it was today in core because we had an arc sine function and we had to do 4 derivatives of arc sine, right, in order to get that max value. So anyway, so that one's not as much fun. This one though is not bad because it's alternating. So we're going to practice how to do this in our calculators. And the first thing I want you to do is type this whole thing, this into
You could do it the other way.
y1. All right, I want you to type, that says y1.
That says N.
Yeah, it does look like n, but it's y1.
My calculator.
That's a great question.
Yeah.
I tried taking the integral of a summation. That's a bad idea.
I'll ask you how the camera stuff.
Yeah, don't put the sum in there.
Yeah, well, I put, no, I mean, like, I took the integral of a summation and it's been loading for the past 5 minutes.
Oh, if you hit on, it'll break it.
I have to control C and I already did and it's
No,
still
it
too
can do
hard
it.
to cancel.
It can do it. Just give it time.
Okay.
Give it time. It'll
So anyway, put this in y1. Include the -1. Include everything in your y1. Remember, it's not which term, literally, it's the absolute value of the term. So when you get your actual terms, ignore the negatives when you're checking. But you want the negative in there so that when we actually find the sum, you can do it. Alright? There's a reason that we're doing this, and actually I have a couple other calculator things to do, but while you guys are doing that, I've got to reset the board. It's way off. Except it's not resetting. Come on. Uh-oh, the board has gone to red. Here we go. Now it's flashing green. It's better.
They're about equally bad.
Alright, well, it is what it is.
What error are we doing?
Less than .001. Only 2 zeros, .001.
Hey, I got it.
Alright, now,
And
So we have to plug in everything except for the -1 to the end.
I want you to plug in the -1 at the end.
Oh, okay.
I want you to plug in the whole thing.
But how is that?
The whole ball of wax.
what kind of a term is that?
Is it Uno?
It's an old expression.
I don't know.
Two, right? So then you do the third sum.
Wait, what is n? How do we do the n? Is that a very
Use
weird
X.
math?
Just use X.
Oh, yeah.
So n equals 3 then?
So,
Yeah, because you started posing.
now n equals 2. It's the third term, but it's a sub 2.
Okay.
That is the error. So you're gonna add a sub 0 and a sub 1.
Wait a second. Wait, can you scroll
Alright.
back up for a second?
Can I do what?
Scroll back up for a second.
Oh, of course. Oh, wait.
Oh, is it just like
You know how for that chapter we have like integrals and stuff, like
How did
Yeah,
I do
chapter
it?
5. Yes.
you do one of those.
I plugged this in right. Oh, that's not right. Oh, shit.
I can try. I honestly can't make a promise on that. I'm gonna give you
I
tons of
did like,
review,
Oh,
but I can't promise that that will be one of the ones. But I will try. Literally, I am overwhelmed with the amount of stuff I have to do, but I will try.
Okay.
So,
This is Mrs. Price.
Oh, it does it there.
Is it?
Mrs. Price? Oh, is this Angie? Hey, Angie. Oh, that's okay. This is 316, and I think he's 2 rooms down. Three rooms down. So he'd be in 319. Oh, that's okay.
Yeah.
Yeah.
Do you like?
Okay.
How much time?
Okay, so, couple quick things. Number one, I found out that your test wants your answer with 8 decimal places. Now, because of that, I want everyone to just stop what they're doing for a moment. Well, finish if you're entering something, go ahead and keep entering it.
Is it
But then I want you to hit mode, like Edna mode. Okay? You don't know what I'm talking about? Yeah. Okay. Okay. Yeah. Okay. Mode. Everyone hit mode? Are you all on mode? You need to be on mode.
Wait, are you trying to just make it
Okay. Write down.
Yeah, it is.
Now, once you're on mode, I want you to look at the line that says float.
Oh, you should.
If you're on a TI-89,
You're superior.
True.
If you're on an expired.
it should say nothing but float. If it says float 6, I want you to go on that and arrow it up until it says just the word float with no number next to it. Alright, everyone got this? This is really important. If you're on a TI-83 or TI-84, then you have float with a bunch of numbers next to it. Make sure none of those numbers are highlighted. You want the actual word float highlighted. What that means, those are the number of significant digits your calculator is going to display. If you just have it on float, it will display as many as it can literally fit on the screen. So if you have it on float 6, you're only getting 6 significant digits for every answer. So you need it on just float so that it's kind of like an auto setting. Float is your best setting, all right?
All in one.
All the other ones are just stupid, yeah. So keep it on float. All right, so everyone got theirs set to float, not float 6? I have had students lose points on the AP exam because their calculator, their TI-89s default to float 6, right? It's just how the way they come out.
Inspire
factor
is
set.
like, I think the Inspire though, like the float, it doesn't do that.
It would just be some zero
Okay,
from
all
You
right,
can just like.
so,
zero to
which one did you find was less than .001?
Those.
It should have been a sub 2, right? So if a sub 2 was less than 0.001,
That means we take the sum from 0.
that means you have to be careful because you're starting at 0, so you have to add a sub 0 and a sub 1. Now I know it's only 2 terms, and I know you could just add them if you wanted to. And remember, to see the whole number, scroll, when you're on the table, move your cursor so that the Y's are highlighted, and look at the bottom of the screen to see the whole number, right? Yeah, okay, so if you want to just do that, that's fine. However, your test, it might not just be 2 numbers being added. It might be the first 10 terms that have to be added, right? And if you have to sit there and write down all of the first 10 terms and add them all together, it's going to take you a long time. So let's talk about how to use your summation formulas, right? So, if you are back at the home window and you want to sum the a sub 0 and a sub 1, right? So, if you're on an 84, you get to that little sigma. What is that, math 0?
Yeah.
Okay, math 0. So if you're on an 84 and you get the little sigma, okay. So you get the little sigma, and it even has little spaces where you can fill in 0 to 1, right? Not 2. 2 was where the error fell below. So we want the preceding terms, right? Just 0 and 1. So you go 0 to 1. Don't spend here you have that little box, right, where you type in the function. Don't retype the whole thing in. Go to vars, then arrow over to y vars, and then hit enter on function, and then enter on y1, right? And then it'll just pop y1 in there.
If you have an 89, can you just type in Y1?
I will tell you that in just a second. So, for the 84, right, just go to vars, y vars, enter, enter. And it'll pop. That's why you want to type the whole thing into y1, so that you don't have to retype it all again. Okay? Are you okay?
Yeah, I actually exited out.
Okay, if you're on an 89, you have 2 options. Alright, so on the 89, you're on the main window and it's F3 and you hit option 4 and you get the little sigma, right? For an 89, they don't have the cutesy little things to fill in, right? You have to type. Here's how you populate Y1 on an 89. You literally hit the letter Y, it's one of the buttons on your calculator, the number 1, and then you have to put of X. It's almost like function notation, Y1 of X.
Like you just do it from
Then you
0 to
do comma X, you always have to tell what your input variable is, comma lower bound, comma upper bound. And of course, on the 89, you have to close the parenthesis. All right, did you get it? Your sum should have rounded to 0.13427, which obviously is not 8 decimals. On the real test, you would have to put all 8. Right? Okay. All right, so another little shortcut on the 89, Shreyas, if you don't want to do the Y1 of X thing, you can always go to Y1 and just do a copy, right? And then go there and do a paste.
Wait, how do you do copy that?
So in your menu, it's like the 4th or 5th choice down, you just hit, like, it's F1 and you just pick copy. Yes?
You can go.
I sure can.
I think it's easier just type in one.
So I'm wondering, Sheldon, so like,
I don't know if I do the like.
Yeah.
The linear remainder.
This isn't Ratatouille. Talking about
Like this was the alternating series remainder. I don't know.
No, just so
Oh, it's something else.
Wait, what is it? Where is it?
Cindy's like a little, like a fake, little slide page, basically.
You have that weird setting too, where it's not defaulting in that spot, it's defaulting
I
here,
figured out
or it's
do what?
trying to get you to do the
Just
integral.
stay in your seat. Arctan of X squared from
You also have stack line
legend.
Wait, no, this is still just.
You're like that Indian guy who figured out everything.
I don't know, I'll have to look into it.
Wow. My other one, I think my other one's still doing, I have 2 brackets like that, the other one's still not working. Yeah, I did have a problem with that. But I had Texas Tech one in mind about that.
Oh, this is mine.
Hey, the quiz is right. I've already done the first one.
If you have,
Viking. Oh, really?
wait, are you sure? Because like these,
Duke is my
like
Vikings.
these two don't have anything down
Yeah,
there.
Viking.
Even a TID
I'm
will
going
have that math.
Yeah,
I
no one's
watched
going
Michigan
to
did it all.
These are
You know, we're Wayne.
I can't believe Michigan actually
So
didn't
let's
mark
just wait
that
until
as
the
the.
district.
He got past all that, but they
They didn't do terrible. They did pretty well.
So
They did pretty well.
Can I run?
So
I'm gonna
they
tell you.
so went to his trial, so bad.
It's a long way to do it, just to go second step.
Number 11, but they just played yesterday. Who did
So,
they play?
second step,
They kicked it off in the basket in the extra
and then you
point.
Hey, Will, who did Michigan play yesterday?
But because it was actually golf, it was awesome.
That
was a wild ride right there.
Michigan wins it all.
Yeah, but isn't like point one of the second one?
Yeah.
You Calvin ball? It's Calvin ball.
There you go, Calvin.
Calvin ball. We gotta play Calvin
Like
ball.
if you win, then if it switches to golf.
What does he
No, that's eight. Okay, good. All right, we've got through one problem. Okay, the next ones will go faster though. The calculator stuff took a long time, right? All right, the next one. The next one now, we're gonna, we have f of x equals arctan x. We are going to use this to find the value of the integral from 0 to 1/2 of x squared times arctan x, right? X squared times arctan x. Remember that arctan, that's our series representation for arctangent.
So we can just multiply that by the series representative for x squared.
So, wait, no,
Oh,
no, it's
no.
even easier.
Oh, it's easier.
Yeah, this is easier than you think. It's,
Oh, just
it's
multiply
gonna
by
be
x
so, it's gonna seem so easy, it's honestly gonna feel wrong, right?
You just
It's
multiply
gonna,
by-
isn't it good to be bad
Oh, you
sometimes?
can just plug in the x squared.
You can't just plug in it, we're not changing our
Like you can multiply the thing by x squared.
Guys, we're not changing our input. We're just multiplying by x squared. Now, if you think about arctan, this is just a sum of a bunch of terms, right? So if we want to multiply them by an x squared, you're just think of it as like an x squared times all those terms, right?
So would it just be?
So you could really just multiply by an x squared.
So is it 2n plus 3 then? X to the 2n plus 3.
So if you multiply, if you want to take x squared times this, you can actually multiply legally by x squared, and you'll be okay. Right? Okay. So anyway, so everyone take a second. Take your sigma for arctan x and multiply it by x squared to get a series for x squared arctan x.
So, when it comes to our upcoming test, should we have like certain ones we memorize? Like,
They'll give them to you.
Yeah, like on homework.
Yes,
Give you and
where they kind of give it to you.
related.
Yep,
Got it. Thank you.
yes.
So do you put the x squared in the sum, or do you just leave it out?
No, I would combine it with this x.
Oh, okay, so you're supposed to dump it in the sum as well?
Yes, yep, it's a part of the sum. Okay, is that okay? When you're multiplying, you just add the exponents. Yeah, you're just adding the exponents. You have 2n plus 1 plus 2, and you get 2n plus 3. Okay? Are y'all okay with this? Now, we need to do what? Integrate. Everyone take a minute. I want you to integrate this series, and then plug in your 0 and your 1/2, and then keep going with it. See if you can find the term that is less than 0.001 on your calculator, and then find the sum of the preceding terms, start to finish. See if you can do it.
Are we ever gonna have some sums where it's like not 0 for the second one?
Not that I have seen.
Okay.
Yeah, it makes me feel better. Isn't that better? I know.
We're only adding one to the whole thing. When you do the intersection. I didn't have the water. So you get your.
Oh, I was doing like that. What? Oh, I was
I know. Yeah.
Okay.
You got it at some two again.
No, I got it 1. So you add everything to it. Equals to negative point. I think I ended it right. So I did it right. No, I'm just asking.
Yeah, I've been kidding.
Did I though? Like, I'm not sure.
I made a mistake.
1 is less than 0.
That's what I got, yeah.
Wait, so
Wait,
then,
why wouldn't, oh, it's 0 for the second and
So how much is I got 164.
wait, you get it from 0
All right, how'd you do with your integral? Did you all match? Raise power by 1, divide by the power? Good. Plug in your half, plug in your 0. The 0 term goes to 0, you're left with this. Plug this into your calculator. Believe it or not, the first term, a sub 1, is less than 0.001. So your sum is just the a sub 0th term, which is pretty nice.
Is that the same as 160?
Yeah, that was pretty stupid.
Yes.
Is it the absolute value of it
Yeah,
that's less than that 0.001 or is it?
Oh, yes, guys, when you're checking to see which term falls below 0.001, ignore the negative, it's the absolute value that needs to be below 0.001. Otherwise, the first negative term would be below, right? So it has to be the absolute value of it that falls below. Good question. All other questions? Yes, Karen?
My calculator is not showing. It's just the same as hers.
Wait, I don't need a graph. What are we talking about?
Oh, well, like, when you plug it in. Do you plug it in? I've got just 0.133 as it is.
Wait. There are whole current thing that we don't have listed here.
So I have the same thing as her, but I keep getting different answers.
So what is? Negative root of the x. You've got a lot of parentheses. Wait, you don't do x. You need 1/2,
so
right?
funny though.
Oh,
That was hilarious.
that's kind of important.
I didn't know what was that called.
Yeah,
Was it
that
you or
changes
was it
everything.
Ashton or Amon that scared you?
Now you've got brackets.
Okay.
Amon
But
and I
I'm just
couldn't
kind of
stop
curious
looking
what's
for like a good solid 10.
Dude, I like legit hate it.
I
Okay,
know.
again, you used the float discussion,
Yeah.
but you didn't do it.
That's such a rare.
Yeah, but what I said was don't ever have a number highlighted, because now you're only going to need some more than figures. What if the first number was 5 point and you need 8 decimals, right? You want it on a float, and that way you can do everything.
Yeah, we
Just
wasted
the word
like
float.
3 or 4 hours. And
Never
then
a
we came
number,
up
always
with,
just
Yeah, yeah.
alright, this time we
Yeah.
shouldn't waste time.
You're gonna get true x's and true values.
Yeah, we're not gonna get on our
Okay,
phones.
yeah, always just have a float.
Guys, when you set your modes, it just, all I want is the word float, no numbers, just float.
Judy's getting, I'm done again. And we're going the same exact way as last year. Conjugate stuff.
Oh, you didn't divide by the whole, oh, no, you divided by the first term, not one. Divide by the whole. Don't put parentheses around the whole thing, it's gonna multiply.
Dude, I had
What time
track of
did
the
it start? How did you do that double?
Oh, you mean like how to
said
do
like
it?
it was right after school and we get on the bus with them, like the same review.
Yeah.
This ruins your birthday.
So he said 6:30.
Yeah, okay.
Your table set is right here.
Yeah, we just have.
Oh, sorry. It's a whole school thing, that's not just for me, that's for cultural relevancy, right? Okay, everyone's going, it's all good. So, okay, there you go.
So his birthday on Saturday too?
No, it's not Saturday.
Yeah,
Oh, yours is before school. I did, like, happy birthday, Michelle.
no, I little reminders go by half hours, so I just put it for sure. All right, good. So let's move on. Good, I think we're getting the kinks out. This is the problem that we need to focus on though. So are we ready? Okay, I spent way too long on the calculator, but you know what, it's a good thing, because it's better to get the calculator stuff figured out now. And here we go. I'm gonna walk you through this. I need total concentration. Here we go. We are gonna use this power series right here to represent this function right there. Now, we have a 1 over 1 minus x. The first thing that stands out to me that's even remotely similar is the 1 minus x squared, right? But there's one thing you can't do with a series, right? You can multiply, life is good. You can divide, and life is good. You can change your input, and life is good. You can differentiate. You can integrate. What do you think you can't do?
Can't change a negative sign.
Okay, one other big thing though, to go from here to here, you can't square it. So, yeah.
Partial fraction.
So, bummer. So anyway, instead, what we want to do is see how, and I'm going to put it right here for the video. I wish I could move everything down. Maybe I can. Okay,
Could you do this?
there we go. All right.
So like the stuff on the homework.
So,
Is it for-
so one of the things we want to do is to see if we can figure out how to make this relate to this. I'm going to ignore the top for the beginning and just focus on that guy, and then we'll build the top after we've got the bottom, all right? So this guy up here is 1 minus x to the negative first. This guy is 1 minus x to the negative second. Now, we need to think of how to get from here to here or here to here using only multiplication, division, differentiation, or integration. One of those 4 things. Yes. All right. If you take the derivative of this, you get this. Is it off by a negative or is it spot on?
Off by negative.
Oh, I
No,
hear
it's
some
spot on.
spot
The
on.
negatives cancel.
Oh,
Because you
spot
have
on.
the negative 1 and then the spot. So
Oh,
it's just-
yeah.
Good. Very good. I love it. Okay. Beautiful. Yes. So we know that the derivative of this is that. Okay. So in order to start, I'm going to kind of walk you through this. So here we go. So ignore, I was just kind of saying, oh, look, you can pull the x up front. Let's just focus on this. So we're going to focus on this first. Oh, good, it's working. Okay. So 1 over 1 minus x squared is the derivative of 1 over 1 minus x. We just said that. So you always want to think, how can I relate it to what I'm given? Using one of those simple operations, right? Okay, so I need the derivative of 1 over 1 minus x. Well, we were given the series for 1 over 1 minus x. It's just the series of x to the n. So all we have to do is take the derivative of x to the n. So the derivative of x to the n, the sum, the series x to the n, is just n x to the n minus 1. Are you with me?
Yes.
So now what we've got is this equals that. So now we have a sum, a series representation of 1 over 1 minus x quantity squared. All right.
Why do you start at
Why
1?
do you change to any?
Yeah, why do you change to n equals 1?
Oh, good question. Okay,
'cause you
thank
can
you.
never
Wow,
have
you
a
guys
negative
observed this.
exponent.
That's really good. Here's the thing.
What?
This,
You can't have a negative
and I
exponent.
have it straight from Mr. Thomas, because this bothered me. But, so I asked him about it today. And he said, absolutely, it's 100% totally fine and very much accepted to just change the starting n, because you can't have a negative exponent in a sum. So, if you had a 0 here, you'd have x to the negative first. That's bad. We can't have bad. You can't divide by 0. You can't have a negative exponent. There are some big rules. So so I was saying, but are these really equivalent though? They are. It's okay, because anything prior to that would be excluded. So it's okay to go ahead and shift your n appropriately so that you don't have either division by 0 or negative exponents.
But integrals stay as 0 because it's like n plus 1.
As long as you don't have division, yeah, you don't want to go to negative n's,
Okay.
right? So yeah, yes.
I may be missing something, but why'd we drop the numerator?
Oh, we're just we're gonna build. This is where we
okay.
wanna end up with,
Okay.
but you can't just start there, right?
Oh, right.
So I'm gonna start here and kind of build it.
Alright.
Alright, we're on step one.
Okay.
Okay. Alright, good. So are we all okay with step one? Now, I'm gonna get this x here, alright? So if I want this x, I've got this. How could I turn it into, ignore the 1 plus, how could I turn it into x over 1 minus x squared? Times by x, right? We already learned that it's okay to times by x. So everyone just figure out what x over 1 minus x squared would be. And all you have to do is take this, multiply by x.
Just x to the n, x to the n. Oh my god. I don't understand this breaking it down so far. When we had x squared arctan x, we just multiplied by x squared, right? So could we do the same thing here where we just multiply by 1 plus x?
You can't multiply by the 1 plus, but you can
Okay.
multiply by x. I'll show you how to build the 1 plus in a second.
Can we go back to n equals 0?
You can, but it's not gonna be helpful yet. Let's just stick with n equals 1 for a little bit.
It just bothers me.
I'm sorry it bothers you.
Why is it snowing?
All right, we're gonna stay on track.
Staying on track.
Okay, so here we go. Now, wait, shh. Guys, I cannot lose you. This is where it gets really tough. Are we together?
Yeah.
Okay, look carefully. Ignore the x that's out front and just look at this. All right? We want 1 plus x over 1 minus x quantity squared, right? We know what 1 over 1 minus x squared is, and we know what x over 1 minus x squared is.
Oh my god.
Did you just figure it out?
Oh my god.
So 1 plus x over 1 minus x squared is literally 1 plus x over what you just literally take what 1 over 1 minus x squared is plus x over 1 minus x squared and add them together.
Okay, now
Okay? Now, does that make sense?
My mind's blown.
Okay, I'll give you a minute to digest.
wait, so what do we do now?
But we're not done. We're getting there.
Oh yeah, because there's still an
Oh, okay, so I thought you were going from I remembered, I thought
Oh, so then you have x to the n, and then finally I have x to the n, and x to the n.
How do you add that? Well,
When you multiply x.
How do you add like these together?
Like, how do you?
No, you have to multiply the whole thing by x still. So you'd have nx to the n. Oh,
Lower box.
How do I add this? Think about, algebra. Yeah, okay. Good. All right, has everyone gotten to a point where they can mentally accept to here?
Yeah.
Good. The next part is one of the trickiest parts. I talked to Mr. I'm going to teach you how to do it. I'm going to walk you through it. If you are thrown, it's not going to be that drastic of a deal, all right? So he said that even though it's like a good thing to know how to do, it's not like this is a make or break where it's going to be vastly important. So I'm going to show you how to combine these together, and I just need you to stay with me. Here we go. In order to combine two sigmas, the first thing you need is you need like terms. If I have 3x squared plus 3x cubed, I can't add them together. They're not like terms, right? So I've got to make sure that the x's have the same exponent on them, right? So The easiest way to do it is to deal with the lower one and make it higher. Unless you're starting with 0, then deal with the higher and make it lower. It's okay, let's just go with it. So, here we go. I'm gonna keep my ends with 0s and 1s, I don't wanna get into 2s and 3s and 4s. So, I'm gonna take this one and make it higher. So here's the thing. When you add 1 to the ends in your formula, you subtract 1 from the ends in your sigma. And here's why. If I plug a 1 in right now, I get 1x to the 0. What I want to do is have an equivalent function where this is not an n minus 1, it's just an n. So, okay, ignore this guy for a minute and just look at this guy right here. Okay, and just look at this guy right here. So if I have a sum as n goes from 0 to infinity, and ignore the n for a second, let's just look at the x's. If I plug in a 1 here, I get x to the 0. If I plug in a 0 here, I get x to the 0. This for the x's and this for the x's are equivalent. Does that make sense? Okay, now, I also, if I plug in a 1 here, I get 1. So I need to plug in a 0 and get 1, so I'm going to make this an n plus 1. Alright, and now I plug in a 0, I get 1. I plug in a 1, I get 2. I plug in a 2, I get 3. It's equivalent. So what happens in general is if I add to these ends, I subtract from this one, and vice versa. So anytime I need to make my x's the same by adding or subtracting from the exponents, I can alter my ends to adjust. Here's the next problem. The ends have to match. Okay? So now this guy's out. Now I've got this plus this, right? But I can't have one sum that starts with 1 added to a sum that starts with 0. So here's what I'm going to do. I'm going to alter this now to start with 1. How can I do it? Well, if I think about it, the 0th term of this, if I plug in a 0, is 1 times x to the 0, so it's just 1. So this sum right here is actually equal to 1 plus the sum as though it started from 1. Keeping the 1 on the outside. Yes?
Couldn't you just change the other one to starting from 0?
You could, but then if you take that one to start it from 0, the problem with that is if you alter this to start with 0, now you have to alter your x back. So you either have to, if you're going to start this, then you got to subtract the 0 with it. Or you start this at 0 and, wait, wrong here. Or you start this at 1 and add the 0 with it. Either way, you're going to have to get it adjusted. Yes?
Are we trying to change the n to 0 or 1, because I'm very confused which.
All we need is for them to match.
We're changing it to 1 now.
We just need them to match. So this is what we had. Sorry, I crossed that off. This is what we had. So in order to get something that matches, this guy right here became that.
Okay, and is that the one in the brackets, is that x over or 1 over? Which term are you working with? Because we have 2, right? 1 plus x, is that x over?